Hello JLM aspirants, myself Amarendra Reddy from SAIMEDHA Koti, Hyderabad. So here I am going to deal with some questions related to electrical measurements, and these questions are generally useful for your JLM exam. So to get confidence in this subject, please follow this session and focus on this discussion useful for your exam, and try to utilize this opportunity. And here we are offering complete online course for these 2 months just only for 1499 rupees, and again we are even providing the test series which comprises of 45 exams, various exams, especially covering the entire syllabus, which will be useful for your exam point of view. And if you easily follow with this procedure, means online course as well as the test series, you can easily crack the exam. So please follow these sessions and utilize this opportunity and try to get the success in this. So let us look into these questions one by one. So if you observe this question, in a PMMC instrument, gravity control is used for controlling torque purpose. If TD is the deflecting torque, and theta is the angle of deflection, and I is the current flowing through the moving coil in the PMMC, then what will be the relation here? Especially if you see this PMMC instrument, okay, name itself indicates permanent magnet moving coil instrument. So what it is indicating? Permanent magnet moving coil instrument. And here if you see this deflecting torque is nothing but BAN into I. So you can easily memorize, okay, right? Keep on revising like ban I if it is our PMMC instrument, where B is the flux density in the air gap, that is in our operating field Weber per meter square, and A is the cross section area of the coil, it is meter square, and number of turns there won't be any unit. So all these are constants in a particular instrument, and you can easily directly say that deflecting torque is directly proportional to current flowing through the PMMC instrument. That is the reason why PMMC is only suitable for measurement of DC quantities, because unidirectional current is there. So it will not detect the AC quantities. Okay, that is different. So deflecting current is proportional to current flowing through this. So you can choose TD proportional to I only. But here for controlling purpose we have two options. One is gravity control method, and other one is spring control method. What we are saying? Gravity control method as well as spring control method. Look at here, if it is gravity control method, right? So gravity control method means we are using gravitational force, okay, for providing the controlling torque. So here how it is attached, this is our pointer. So pointer is attached to a control weight which is placed in vertical position, okay, with the length of L and having a weight of W. So it is attached to this, right? And here scale is present in our instrument. So this is pointer. Got the point? So pointer is attached with this control weight. So whenever deflecting torque is developed in the instrument, due to deflecting torques, so automatically pointer is moving towards this amount of deflection. Then this weight is also attached to this, and definitely it is also making movement because it is attached with the pointer. Same amount of deflection will be there, and the length is also same, weight is also same. So at this moment, means here two forces are acting, one is acting in downward direction, other one is acting in this direction. It is similar to our simple pendulum. This is sine component, and this one is cosine component. So we are not leaving this object, okay, so it is attached to this pointer. So definitely when you remove the supply from the instrument, definitely deflecting torque becomes 0, then controlling torque is acting in this direction. So because of that, this control weight will come to this rest position. So this force will be the what useful force. So controlling torque is equal to WL sin theta. So these are what constants. So TC proportional to sin theta if it is what gravity control method. Suppose if I am going with what spring control method, so what we can have, spring control method means we are using what helical structured spiral spring. What we are saying? Helical structured spiral spring, which is made up of pass per branch material. This is also important question. Which is made up of pass per branch. Sometimes they ask spiral springs are made up of which material? Pass per branch material. Okay, helical structured spiral spring, okay, which is made up of pass per branch material. Okay, helical structured means like this. Got the point? So it is similar to our hairpin, similar to that. And here we have empirical formula. So how we are going to write controlling torque TC is equal to, okay, 12L, right, WL sin theta, sorry, EB T cube by 12L into theta. Okay, for this particular spring all these are constant, where E is the what Young modulus of the spring and B is the breadth of the spring and T is the what thickness of the spring, where L is the what length of the spring. For a particular instruments all these are what constant, so we can easily write TC proportional to theta. Means spring control method means TC proportional to theta. Gravity control method means what we write here, TC proportional to sin theta. So if you just observe the word question, in a PMMC instrument, okay, deflecting torque is proportional to current flowing through the moving coil. And what will be the controlling torque if it is gravity control method? Observe the word statement here, gravity control method. Gravity control method means TC proportional to sin theta. So where that option is matching, TD proportional to I, and whereas controlling torque proportional to sin theta. Look at this. So such questions only you can expect, okay, very basic questions, expression based questions, and if you really observe the questions, quantity, okay, what quantities these are going to read, means AC quantity or DC quantity, such questions only you can expect, okay, in our exam. Okay, please focus on these questions, okay, which will definitely useful for your exam point of view. So let us move on to the what next question. So for this question, this one will be the correct one. So next question, if you see, in moving iron type voltmeters, the marking on scale, okay, how the scale is associated in what moving iron type instrument. Observe here. So basic instruments we have PMMC, which is generally for what PMMC is for what only DC quantities, or it will read what average values. And here deflecting torque is proportional to I. And if it is what moving iron type I am indicating with MI instrument. MI instrument is reading what both AC as well as what DC quantities. Here deflecting torque proportional to square of the current passing through it. And if you observe the what expressions here, how the deflecting torque is present, what will be the deflecting torque expression in our moving iron type instrument, TDF, which is equal to I square by 2 into dl by d theta. So where dl by d theta is a what change in the self inductance with respect to deflection. So here if you observe, if I am following with controlling torque, right, so controlling torque, that especially I am following with what spring control method, then what will be the controlling torque here? It is proportional to Kc into theta. So let us utilize these expressions and observe this. TDF is equal to what? I square by 2 dl by d theta, and again controlling torque is equal to Kc into theta. So whenever both are equal, means deflecting torque is equal to controlling torque. So when both are matching, okay, right, so Kc into theta is equal to I square by 2 into dl by d theta. So from here theta is equal to I square by 2 kc into dl by d theta. So from this particular instrument, theta proportional to what? I square, if I consider remaining or what? Constant. Theta proportional to I square means how the scale is related, how the deflection is related with respect to current flowing through the what? Coil, how it is related, it is like this. So it is a non-linear, scale is what? Non-linear, or we can even call it as non-uniform. We can even call this as what? Cramped scale. Got the point? We can call this as a non-linear or non-uniform or cramped scale. Means when you design the scale, how it is present. Look at this. If you observe here from starting to ending, only from this portion we can have what? Linearized portion, right or not? So here it is having some linear behavior or uniform behavior. Means even if I design the scale from starting to what? Ending, how it is associated. Look at this, starting will be like this. Okay, starting will be like this. Okay, means starting cramped scale we call. Here also cramped scale we have, only in the mid values we can expect what? Linear portion. So here only we can have some linear portion, means uniform distribution. Again at the end also again crowded, means non-uniform distribution. So here it is really difficult for us to recognize, means starting and ending we have what? Cramped nature, means overcrowded, means values are very near to each other, but only in the mid range you can have the what? Uniform behavior or linear behavior. So how we say generally in moving iron type instrument, definitely starting ending will not be giving any priority in designing the scale, because values are overcrowded and it is really tough task for us to note down the what? Readings, okay, when you design scale from starting to ending. That is the reason why MI instrument generally from 80 to 90 degrees only we design the scale, means only in the mid range, because starting and ending will be having what? Overcrowded, means what you can say, crowded at starting and ending will be the what? Correct option, because of non-linear behavior, right or not? PMMC means it is linear instrument. You can design the scale from starting to ending because we can have uniform distribution. So absolutely no problem when you design the scale for PMMC. You can choose from starting to ending, no problem at all. But in moving iron type instrument you need to design scale only in the mid range, because starting ending will be having crowded. Even though if you design, it is really tough task for us to recognize the correct reading. That is the reason why we are going with this option. Understood? How we need to differentiate the what? Options when it comes to our question. Follow the what? Basic expressions, based on that only we are commenting. Really it is very easy subject, but you need to have right direction and you should follow the right direction, then only you will score more marks from this area. Let us move on to the what? Next question here. Okay, if you see this, and again most important topic, that is 2 wattmeter method in 3-phase power measurement. Compulsory we can have a question every year from this. Means if you take any competitive exam, generally we get question, and even for JLM aspirants also you can easily focus on that, because we can easily score questions from this area. Okay, easily you can get. That is the reason why we are stressing. So sum of the readings of wattmeters is how much here? Sum is W1 plus W2 is given as what? 900 watts, and difference of readings is how much they indicated, that is W1 minus W2 is given as what? 450 watts. Okay, and to measure 3-phase balanced power using 2 wattmeter method, then the readings of both the wattmeters is asking, at the same time power factor also is asking. It is really easy to find, okay, right? How to get some readings, individual readings means you need to just add both readings. So 2W1 is equal to how much we get here? We get 1350, and W1 is equal to 675. watts, and W2 is equal to 900 minus 675 means 225 watts we will get. So individual readings we got. Now the rest of the thing, okay, we have two options, means once you are able to find correct power factor, then only you can get. So how to get power factor? Power factor is nothing but cos phi. We need to have cos phi. But when we have two wattmeter readings, we know tan phi. What is tan phi? Tan phi is equal to root 3 into W1 minus W2 by W1 plus W2. Look at here. Root 3 into W1 minus W2 is how much? 450 given already. Difference. W1 plus W2 is given 900. So tan phi we identified it as what? 450 by 2. 450 by 900 means 1 by 2. So tan phi we got it as what? Root 3 by 2. Then how to get what? Cos phi? Without even calculator you can do that. Look at here. Tan phi means I am making what? Right angle triangle here. Got the point? I am using right angle triangle here. Okay. So this is what? Phi. Tan phi means root 3 by 2. So this portion is what? Root 3 and this is 2. How to get diagonal portion? Diagonal is square root of root 3 square plus 2 square. If you do, will get diagonal part. Root 3 square means 3 plus 2 square means 4. So which is equal to root 7. From the right angle triangle, what is cos phi? Cos phi is equal to 2 by root 7. So directly power factor you can get from right angle triangle. Okay. So instead of going with finding phi from this again cos phi, it is really tough task because of these values. Even calculator not allowed. So cos phi is equal to 2 by root 7. So if you check all the options, only first one is matching with our calculation. So in that way you need to find the what? Power factor and the wattmeter readings from this. It is very easy. Okay. So next move on to the other question here. Again we are taking one more question from 2 wattmeter method. In measurement of 3-phase balanced power, 2 wattmeter method is used. If 1 wattmeter is reading total power consumed in the circuit, then the power factor of the circuit. Look at here. Here I am going to make a table for the what 2 wattmeter method, which is most important. You can even get a question from this. So here I am going with phase angle, phase phi, and power factor cos phi. Okay. And wattmeter readings generally we get root 3 VL IL. Okay. Sorry, not root 3. VLIL cos of 30 minus phi is 1 wattmeter reading, and another wattmeter reading is what? VLIL cos of 30 plus phi we will get, and total power we are making, and any observation we are writing in this column. So this is really useful for exam point of view. This table is enough to answer question from what 2 wattmeter method. Let us look into different values of phase angle. If I start with phase angle 0, what is cos 0? We know that cos 0 is what? 1. 1 means that is unity power factor, and when phase angle is 0, what will be the reading? VLIL cos of 30 minus 0 means cos 30 root 3 by 2 VLIL we get. Even this one also will give same reading, root 3 by 2 VLIL. So total power will be what? Simply root 3 VLIL if you add these two readings. So what you identified? Both the wattmeters are giving same reading. Okay. So now if you move to the what other phase angle 30 degrees, what is cos 30? Cos 30 means root 3 by 2. Root 3 by 2 is nothing but 0.866. So cos of 30 minus 30, cos of 30 minus 30, cos 0 is what? 1. So VL IL, and the next reading VL IL cos of 30 plus 30. So cos 60 means 1 by 2. So VL IL by 2. What you recognized? First wattmeter reading is what? Look at here. Observation we write in the here. So 1 plus 1 by 2 means 3 by 2 VLIL. So what will be the observation here? 1 wattmeter is what? Reading 2 times of another one. Next, if I am following with 60 degrees, cos 60 means 0.5. Then VLIL cos of 30 minus 60. Cos of 30 minus 60 means cos of minus 30 is also positive. Cos 30 means root 3 by 2 VLIL. And next one, VLIL cos of 30 plus 60, cos 90 0. Okay, total power is only because of 1 wattmeter reading, that is root 3 by 2 VLIL. What is observation? 1 wattmeter is reading what? 0. Okay, right? So now 90, if I take cos 90, what? 0. 0 power factor. Cos of 30 minus 90 means cos of minus 60 is positive, that is VLIL by 2. And the next one is what? Cos of 30 plus 90, cos 120, second quadrant cosine is negative. So VLIL by 2 we will get. Total power is 0 because 0 power factor. Both are reading same quantity but sign is different. So what is the question here? In 1 wattmeter, okay, in 2 wattmeter method, if 1 wattmeter is reading total power consumed in the circuit, then total power is only because of 1 wattmeter reading, and 1 wattmeter is reading 0 means what will be the power factor? 0, 0.5. So this one will be the what? Correct option here. So 0.5 is the what power factor, or the phase angle is 60. At this position only we can have total reading is only because of 1 wattmeter. Got the point? Understood? And another wattmeter is reading what? 0. So wonderful table. Okay, if you memorize this table, you can easily answer question from 2 wattmeter method. Understood? Please follow this. This table is most important for you exam point of view. Okay, let us move on to the what? The next question here. Okay, so what we have? A PMMC voltmeter is connected across a series combination of 2 volts, like V1 is given what? V1 is what? 2 volts, and other one source is having what? V2 of t is equal to 3 sin 4t. Both are connected in series across our PMMC voltmeter. PMMC voltmeter. How it will read? PMMC reads what? Theta proportional to I. PMMC reads what? Only DC or average value. PMMC reads what? DC or average value. It will not respond to AC quantity or RMS value. So it will give only reading because of what? 2 volts. It will not respond to 3 sin 4t. So 2 volts is what? Correct. Understood? If it is moving iron type instrument, it will read both AC and DC quantities, but it will give what? RMS value. Observe the difference here. Which meter is reading which quantity is most important, and majority of the questions are only based on that. Okay, so we observed some questions here. So in the next sessions we are going to deal with some other kind of possibilities, and which will be useful for your exam point of view. So please utilize this opportunity and try to get success in that. And we are offering this course with very less amount of price, okay, for this online course, and valid for 2 months. Please utilize this opportunity, and we are offering this course just only $14.99, and the validity is for what? 2 months, means up to exam. And with additional to this, we are also providing the what? Test series, and which comprises near to 50 exams. Means individual subject wise as well as even grand tests also we are providing with this package. So please utilize this opportunity and try to get success in this JLM notification. All the best to all the JLM aspirants. Thank you.